All right, ladies and gentlemen, so example 2. Haha, the kids at school got to draw this as I was doing it. You don't. Pause the video now and draw it and then join us because I am moving on. So I have a graph here and it's filled with a whole bunch of different sections for f of x. All of it is f of x. Now I'm interested in the continuity at certain points. So what I'm going to ask is, the question's going to say, for what values, now pay attention to the way the questions are worded. It's important because you're going to start doing your homework and I don't know, you'll have a question that says use the limit properties to solve something and you'll just go ahead and use the mega property and you'll get a really easy answer. And that's not what's supposed to happen. Please go back and check. I'm going to put a video up about question number 12 and 13 in your post. It'll be near the end. Make sure you take a look at those. But anyway, read the questions. For what values of x is f of x discontinuous? And why? Okay? So I want to know for what values are we going to be discontinuous, and I'd like you to tell me why. Okay, so the first one. First of all, do I have to go over the conditions? Let me put the conditions up here. So if I was doing this question, the first thing I would say is, well, the conditions for continuity at any point is that the limit from both sides of the point has to exist. And the function needs to be defined at the point, and they have to equal each other. So this is actually 3 things in one. Isn't that awesome? 3 conditions. So the first one is the limit really does need to exist. Otherwise, there's no left-hand side, and let's stop talking about it. Number 2, f of x must be defined at x equals a. And this should say this has, yeah, well, that's fine. And the last one is where I care what they actually equal. And that's where, yeah, well, they have to equal each other, because if they don't equal each other, then I end up with a gap, right? Things are going to jump around and things aren't going to work very well. So where are we going to have a problem? We probably should start from left to right. That just makes sense. So we'll start over on the left-hand side, and we'll start working our way to the right-hand side. So I hop on the graph, and we start moving, and we let x start moving this way. And so my Silver Surfer's doing just fine until he hits here, in which case he falls through and he goes, ah! And that's bad. Okay, that's bad. So that is a discontinuous area of the graph. So our first area of discontinuity is at -2. So x equals -2, f of x is discontinuous at x equal -2. Yeah, that sounds good. I used full proper statement there. That's so nice. And why? Well, we got a problem. It's actually, this is called a jump by most textbooks. They're going to call that a jump, because I had to go along this one and then jump to this one. And what fails on a jump, really, the first thing to fail is your first condition, right? Your very first condition fails because the limit as x approaches -2 from the left of f of x is not equaling the limit as x approaches -2 from the right of f of x. So my very first condition fails. And look at how I wrote that. Isn't that beautiful? I gave a reason. I'm explaining it. I'm not getting into the numbers or any of that garbage. And it's beautiful. And that's what I want from you guys. I want you guys to be able to speak intelligently about these things.
Is that I there, just like your explanation?
Yeah. So it meant this one. That was the condition that failed. So the question was, why did I put an I here? Well, it's condition I that failed. Yeah. So I guess the next thing to do is, where else is it going to fail? So I'm going to continue along. So Silver Surfer has now jumped down to here, and he's going to go, wee, ah, ah. Whoa, that's pretty rough for Silver Surfer. Did you see what happened there? Silver Surfer went, wee, wee. So, yeah, he's got a headache after that one. So that's definitely some discontinuity happening there. So at x equals -1, f of x is discontinuous. And now, why is it discontinuous there? Well, a couple of reasons. The first one is the limit doesn't exist. That's a problem. So the limit doesn't exist. The limit as x approaches a of f of x does not exist. And I'm going to save some time because it's video and everything. But if this was a test, I'd do this first, okay? I would show why it does not exist. I give some reason, but I don't want to keep doing the same thing over and over with you guys. So we know that that doesn't exist. So condition I is not working. There's another condition. Well, no, once that's done, you're done. Condition 2 actually satisfied. It is defined at that point, and there's no point talking about condition 3 because there's no left-hand side. It can't equal each other. So don't tell me condition 3 fails. Well, I guess it does, but we can't even start talking about condition 3 because it doesn't exist. And this type of discontinuity, where you have to go, for some reason, a double jump, they like to classify as a gap discontinuity. I don't know why. I don't know why they swallowed the fly. Okay, so C. Where else are we going to go? So Silver Surfer is now here. And he's going this way. And that little bump, he doesn't care. That's a cool little bump. He's going to go up over that bump. That'll matter later. Later we're going to be upset with bumps like that when we talk about other things. But not for continuity. That's just a little bump. So then he bumps over and he comes up. And notice that he keeps going and going and going and going and going and going. And he never comes back. And it's really sad. We say bye. And then he's gone. So the curve is actually discontinuous at x equals 2. He's gone. He's never coming back. So what failed here? Well, again, the limit doesn't exist. The limit from the left and the right of 2 doesn't exist. That definitely failed. But it failed a particular way, didn't it? It failed by going to positive infinity on both sides. And so we want to include that. We want to keep that information. And what that really means is that there's an asymptote. There's a vertical asymptote there. That's what that definition of a vertical asymptote is. And sometimes when they talk about this, they talk about it as an infinity discontinuity. And the two are different. You don't always have a vertical, well, do you? Yeah, you do. You always have a vertical asymptote wherever you have an infinity discontinuity. It's the same thing. And bottom line, it means that my curve is broken. There's a gap in my curve, and it's because that there's an asymptote there. Okay, so now let's pretend that somehow the Silver Surfer got off this line. Somewhere up here, he stepped over the asymptote, okay? And then he started coming down the curve again. Good old Silver Surfer. And here he comes. Now he's going to have to duck as he goes under this one, right? Well, actually, that's kind of drawn improperly. That hole needs to be right about there. So there's no ducking. So he's coming. They go, don't. Okay, so that's a problem, right? This is going to hurt. This is going to hurt poor Silver Surfer. So we are discontinuous at 3. F of x is discontinuous. And that type of discontinuity, once again, it's a double jump, isn't it? So he's coming down here, and he has to jump up, and then he has to jump down. And, well, to be honest, they call that a gap. So again, that's a gap discontinuity. And it's really not as nice as you think about it, because this transfer from this line to this line has to be instantaneous. There is no real gap there, is there? If you think about it, because you're getting closer and closer and closer and closer and closer to 3, and then all of a sudden at 3 you got to be up there, and then all of a sudden as soon as you step off 3 you got to be somewhere else. So once again, very painful for Silver Surfer. What fell apart here? Not condition 1. Not condition 1. Condition 1 is fine here. This limit exists. Okay, condition 1 is A-OK. Yeah, I'm good with that. Condition 2 is A-OK. It is defined. F of 3 is definitely defined. Condition 2 is definitely good to go. What's the problem? They don't match up. Condition 3 is my problem in this one. Okay, and that's giving me that gap discontinuity. Can you foresee me asking you a question on a test that says, okay, you've got a limit where the two-sided limit exists, and you've got a limit where f of x is going to be defined. What type of discontinuity is it? Please draw me a graph. I might ask you to draw your graph, in which case you can draw anything that works, okay, as long as it satisfies what I'm giving you here. So we need to be able to make sure that we know what this means in terms of this and what this means in terms of this. We got to know both. And the last part, we're looking at discontinuity. We have discontinuity here. We have discontinuity here both if I'm just thinking of the left hand going to A. So it's definitely discontinuous approaching x equals 4 from the left. It's definitely discontinuous coming from the right because it's not defined anywhere on the right. And it's also discontinuous at 4, but the problem is that this limit, this two-sided limit, doesn't exist at 4 in both directions. So we'd have to be careful how we talk about that. And you also know that f of 4 isn't defined at all. So everything's falling apart here, right? It's a whole, that's just a bad situation. Okay, I'm going to pause the video there and we'll be right back.